Actually, the more you interrupt, the better, as long as it's relevant, if that makes sense. Okay, so I'm not going to go through a lot of these. I did want to just show you the list of normal forms. So this is the unnormalized form. I mean, that's basically what we have in that diagram I had to do. First normal form we're going to go over here in just a minute. Second normal form, third normal form. Most database experts and most textbooks agree that third normal form is far enough to guarantee that your database should work. Right? It may still have a little bit of, it could be refined more, but if you get through third normal form, everything should work. These are all further refinements. And so, but unless you're going to be a data scientist, you probably don't need to know all of these. It wouldn't hurt to go look at these, but the effect of, you go all the way through all of them, is you end up with tables that often have only 2 or 3 fields that are mostly foreign keys and keys. All right, you end up with a lot of tables and they're very finely sliced. The disadvantage of that is performance. The more tables you divide a database into, the slower your performance will be. It doesn't matter usually unless you're something like Amazon with hundreds of millions of users and hundreds of millions of probably billions and billions of records. Then it matters a lot. At Amazon, they do a thing called denormalization, and we don't need to worry about that too much, but they recombine a lot of the tables into a search table for customers so that it'll be fast to do the searches. The disadvantage of that is you could buy something that they don't have anymore because it's not live. They update the table fairly frequently, like probably every few moments, but it's not live, so it's always possible you could buy something that they don't have anymore. But it is well worth, it is less of a problem for them to have to apologize once in a while than to have you wait for the results. And it doesn't happen very often. And I suspect if they didn't have it, they'd go scrounge and try to find it if you bought it and they were out. All right, so let's talk a little bit about what first normal form is, and then we'll look at our diagram and try to go through it. And I will post all of this on the blog, and then there will be this video, thanks to you for reminding me. I have gone a whole class with the video set up ready to go, and then at the end of the class realized I didn't run it. So, first normal form. Basically, and I'm doing this, if you ever want to read the actual normalization papers, they're written in kind of predicate logic, kind of a very formal language. You know, if you ever read World Wide Web Consortium papers, they have 2 of them. Weirdly, there's a normalized and a not normalized version. The normalized actually means that they've turned it into English. The not normalized means that it's in the pseudo-mathematical, I don't know if it's pseudo, but it's the predicate logic in the very strict sense. Because when you're building a programmer, regular English isn't strict enough to tell you exactly what you need to do, you know, when you're doing these. So anyway, the papers are generally written in that mathematical kind of language. But the concepts aren't that hard, particularly for the first 3. You guys remember I've mentioned a couple of things. So one of the parts of this is that every attribute, and remember attributes are basically just a column, must contain, how do I want to put this? All the data in an attribute. Let's put it, so you type this and then I undo it. All the data in an attribute must be of the same kind. All right. So this is both a logical and also the data type. We'll deal with data types in a week or so when we're doing. What is it? What do you think I mean by that?
You probably don't want like an integer and a string in the same attribute.
Right. So basically, if you have a column of dates, everything in that column must be a date. Does that make sense? If you have a column of emails, they should all be emails. You don't want to mix a column like email/phone number. You don't want that. Even if they're all the same data type, like strings, you don't want a table that says like apartment name, employee name. So you have all of your employee names, but occasionally you slip in like human resources or something for a department name. You need to separate them. Everything in an attribute, everything in a column should all be of the same kind. Does that make sense? And then the other thing, basically no lists or arrays in those columns, in those attributes. We talked a little bit about this. What would a list be like? Let's say you had a CD and it had lots of tracks. So a list would be like track 1, track 2, track 3, etc. And let's say you decided, because remember, tables don't expand and contract, you know, in terms of the amount of data, yes, but in terms of the columns, they don't. So let's say you determine that the average CD had 13 tracks. That's about right. What happens if it's a prog rock one and it's only got 1 track? then what you have is 12 empty columns, right? And what happens if it has 14 tracks? You don't have a place for the 14th. The other problem with it, and this may be even a bigger problem, let's say you wanted to find a particular track. You would have to query 13 different attributes to find it, right? So it's just, you never want to do that. The other, an array would be like, where you have, I'm going to do it as string. Track 1, track 2, track 3, etc. And you could go as many tracks as you want, but they're all listed inside of a single column. And basically, they're just multiple values separated however you want to separate them. The thing is, again, for searching that, you can only return the string. If you wanted to search for a particular track, you would have to do some kind of substring search using some other programming language to find that. So it's just those two things are forbidden. That's really about all that there is in the first normal form. You need to get rid of all data has to be of the same kind, and no lists or arrays, no plurals, basically. Does that make sense? So let's go to Lucidchart here. Let's just look at what would be listed in plurals. Ignore advisor for right now, because that comes up on the next thing. What would be plural? Majors, right. So if they can have multiple majors, then we should have, and the solution to everything as you go through is to make more entities. So they might, although let's just say they only got 1. Yeah, so I'm going to just do a quick major ID. That's another part that's usually considered part of first normal form, is that every entity should have a primary key. So so we got majors out of there. I want to do what?
Courses and grades?
Yeah, let's bring out years first. Now, years enrolled, we may deal with a little bit differently here in a minute. Can I drag that? Will that drag? No. So I think I just delete it. Whoa! Control Z. All right. So I'm going to do like enrolled. And then I'm just going to do enrolled ID. And I'll do year. You might also, I mean, if you were doing that, you'd probably have like quarter also. I'm going to cut that. And then I'll cut it over here. All right, so then you said courses and grades, right? Mm-hmm. And that has two problems. One, it's a mixture of two things, course and grade, and two, it's plural. So I would put out so I would do a course for sure. I'm going to do course ID. We'll add some other stuff to course in a moment when we fill this out. Grade, let's for right now put it in here. We can deal with it later. So I'm going to just do grade. As I said, this may not be its final resting place. Some of this depends on how, oops, I want to go the other way for right now, on how you define course. We'll talk about that in a minute. Is there anything, so let me get rid of this one.
What about, don't worry about advisors right now.
Yeah, so right now we're just sort of doing the plurals in the list. Right. It's obvious that advisors is a problem. All right, so let's do I didn't put department in there. We can deal with that later if we want to add it. I just realized it's not in here, but that's okay. All right, so
where were we putting it there?
What department?
Yeah.
Well, it'd ultimately be broken out anyway. So let's go back. So I think we got all of the lists and arrays and mixed things out of it, right? So the second normal form all right. So one of the things in all of these, it assumes first normal form, and they usually do these like S and F or 1 in F. Getting that, I want the number. So it assumes the first normal form. All right, and then what you want to do is you want to get rid of structural dependencies. And it's not important that you think that you understand the term, but what these are, they're like subsets. They are groups of attributes that refer to each other or relate to each other, but not to the topic of the entity. Does that make sense? Let's take a look at this. We have all this student information, and then we have all this advisor information, right? So it's really two different things. This is a subset. It's actually a subset that's bigger than the main set. It's a subset inside of this. An entity should be about one thing and only one thing. All right? So the advisor stuff all needs to go into its own. We'll talk about relations and how you relate them in just a minute, but let's do advisor. All right, and we'll give the advisor a key. Is there any way? There's no way to move these, is there? So if I do like advisor name, can I move? No, that moves
Probably
everything.
cut it. Cut copy. You can right click it.
I know, but if I cut, is it cutting? It cuts the whole thing.
Oh.
All right. What I wanted to do is just drag one of these, but I don't. It wants to drag everything. Yeah. It would just be easier if I could drag it. Doesn't matter. Advisor name. Advisor department. There's department. Advisor office. A building. Not necessarily. I have advisor office in there twice, don't I? So I got building. We just need building. Now, if you want, well, we can talk about it in a moment when we do relations. So let's get rid of all the advisor things. Can I do multiple selects? No. There probably is a way. I'm just not going to worry about getting there right now. All right, so we're down to just student. We have major, we have course, we have enrolled. We'll talk about that in a moment. What else? So is there anything else where there's a sub? And we could fill these out a little bit, like this would have like a major, the name of the major. What else would it have?
I think there was courses and grades before. I don't think
Well, we have those
grades.
down here.
Oh, there's grade, yes.
Yeah, and we'll probably, as I said, we might want to deal with that a little differently in a minute. Okay. I think so. That was the big structural dependency. Anytime you find groups, a structural dependency means that there's a group, there's a subset, there's a 2 or 3 attributes that are related to each other but are not related to the topic of the thing. The topic here is student, right? So they have to be direct. It is true that a student can have an advisor. It's not totally irrelevant. It's just that you don't need all of the advisor information inside the student. Right? When we make a relationship, we can put the advisor ID in here as a foreign key. Unless they have more than one advisor, which is. Same with the major. We'll deal with that in a second. Okay, does that make sense so far? As you can see, we've had one entity so far. We've got 1, 2, 3, 4, 5. We're probably going to end up with about 8 or 9. Let's go back to our first thing here. So this next one, where did I do a student? Did it go away? Oh no, it's just small. Never mind. So let's talk about the third normal form. All right, this is real subtle. And it's essentially the same kind of thing that second normal form is. The difference it's to remove any transitive descendant, what they call transitive dependencies, which probably means like Greek to you. the difference here is that when you have a structural dependency, you have a group, you have a subset of things, right? This is just like one attribute that refers to something else, another attribute, but isn't really directly related to the key. So this is like one attribute that refers or is related to another attribute. One of the ones that I often use is like artist and artist country. Artist country reflects the artist, not say it was in the album, not the album, right? Here we do have one, but it's not in student anymore. Does anybody see one where there's a thing that's sort of related to
Grade?
Well, grade is actually sort of a, I think the problem there, we'll get to that in just a second, is that these are two different things. We'll talk about course in a moment. I'm thinking this is really subtle, office and building.
Yeah. Yeah.
What their office number is relevant to the advisor, the building, they're kind of relevant, but office and building kind of reflect each other. So you might actually want, if you're being strict about the third, you might want something like, I'm going to call it location. I'm going to give it a location ID. We're kind of punting on the primary keys. We're just saying they're IDs, whatever they are. And then you would have like a building. So you actually might have, we're going to do that, building. So let's make this building ID. And then building, let's call it name. Call it address. And then you might have like office. Office ID, which could be the office number, actually. Well, let's see. Depends. And then we'd have the building ID.
Wouldn't that be repetitive?
No, actually, I should cut out the repetitiveness to some extent. What do you mean by repetitive?
So we've got building, and we've got a building ID, and then we've got.
Right. So these are all the ID just hooks it to the. I got rid of the thing there, but it's a foreign key.
Oh, okay.
This would have all the building information, and this would just refer to that building, and this would give you the office number inside the building. Does that make sense? And then for the advisor up here, since we removed those things out, this would be office ID, and that would be a foreign key. And then we wouldn't need the building because the building would already be there, right? We might want the departments broken out too. And you could have more fields, so not necessarily filling everything out. That was the only transitive dependency I've got. And again, they're really subtle. And if you don't catch them, they usually aren't fatal. But it's just to keep you from repeating the building over and over, the building name, building address. So you have a thing where it describes the buildings. The office is a room in a particular building, right? And then you don't have to repeat the building now because you're just really, and you could have more information about the office. Does that make sense? Mm-hmm. We'll do relations in a moment. We'll tie things together, but all right. So those are the three normal forms. I want to say just a little bit more about them, and then we'll come and fix a couple of other things in there. The gist of these is that basically every entity should be about one thing. Every attribute in the entity should describe that entity, right? I mean, in a way, that's the gist of all of it. Every entity is about one thing, and every attribute in that entity should describe that entity. Does that make sense? That's sort of the gist of those three levels of normalization. That being said, it's sometimes hard to see that in actual data. You know, when you're building it, it's sometimes hard to see some of those things. So if we go back, we do have something, so we still have course and grade, right? I'm just going to delete that for now. We might add some in a moment. The difference, the trouble with course and grade is that they're really not the same things, right? So let's, a course, let's just build that out a little bit. So we'll get rid of grades, but I'm going to add a couple fields here. So we'd have the course name. And we'd have, oh, don't want to do that, I just want to move that.
Location.
Well, I wouldn't do the location. Here's where it gets into definitions. When I'm thinking about a course, I'm thinking ITC 220, right? So this would, like, how many credits is it? Whatever, you know, else you'd want to describe for a course. I wouldn't, because when I think ITC 220, we've got I've got two sections of ITC 220 this quarter, right? And I think there's at least one other being taught, I think, at night. I'm not sure. So the course I think of is what you see in the catalog. And then I would see as like a section. Does that make sense? Mm-hmm. And again, some of what you come up with here depends on, so I would see a section. A section would have, so a section ID or number, and it would have a course. ID is a foreign key. And then it would have a time, and it would have a room. You might actually, these are offices. I should just say this is room because you could do a room ID here. I'm going to change that to room. Change this to room ID. It's to make it more generic so it'll work for not only offices but classrooms. So I would do a room ID.
You changed the advisor one then too.
Probably. Did I do? Yeah, I was going to. Room ID. I just want that part. Oh well. Okay. So time, room. I would also put in things like, I'm going to add a couple, quarter, year, some of the things that we have in the enrollment up above.
But we already have a table that deals with quarter and year.
Yeah, well, I think I would take them out of there. And there's a reason for that. All right, so what would we do? I'm going to move this down a little. we're going to make a relationships here in a moment. What kind of relationship, and we still have grade hanging out, right? What kind of relationship would there be between, say, student and section? So this is like a section. A section is an instance of a course.
But that would be like, so somehow we have to have like a foreign key a student for.
So yeah, one of the things, so the student will have to be a foreign key somewhere. But if you think of the relation, one student can be in many sections, right? Because you're taking different instances of different courses. Each section can have many students. So it's a many-to-many relationship. We could use enrolled for that, because we could put, so let's do, I'll just do this as PK. Let's add a section ID, and let's add a student ID. So it'll be between section and course, basically. And this is actually where I would put the quarter grade, is in here. Yeah, because this is where you're actually, this is be like the roster. That's another name you could use for it. So I'd put the grade here. So this is the section that you're enrolled in. So you're enrolled in the afternoon ITC 220, not in the morning ITC 220, right? So, and then we're, so this would be your relation there. Does that make sense? Now again, enrolled is you can name these differently. I used enrolled because we named it that before. And I would put, so in the section actually is things that describe what section it is are, you know, the time, the room, the quarter, and the year. That's, you know, and then the course, what course it is. So this is ITC 220 at 1 o'clock in room 3179 or whatever the, you know, the building, what do they call this, BE, Boston Medicine, fall quarter 2018. Does that make sense?
I think the title of the enrolled entity is confusing.
Right, so I would, it might make more sense to name this roster or something.
Or something like class,
Class roster, section roster.
I don't know, it's just calling it enrolled, it seems like that should be something else. But
Yeah, I know. Well, we did that because we threw it out, we pulled it out of the other one. It's perfectly fine to rename things to make them make sense. What? Class roster, course roster,
Well, it should
Maybe
be
class
section
record?
roster.
section roster. What?
I was thinking like class record or something.
I don't know if I'd call it a record. Yeah, I guess you could. Depends on how you. Let's do section roster. That being said, you have, when you're designing this, you're totally free to come up with names that make sense to you and the people you're working with. Anything else? So we're starting to think about relations. This is basically kind of like a linking table. It's not exactly. We said a student could have many majors, right? So what is that kind of relationship does that make? One major could have, yeah, many. It's actually many to many. You were right the first time. One student could have many majors. Actually, that depends. Well, it depends. It depends on a rule that you make. It's a school. It depends on the school. Can a student have more than one major? If a student can have more than one major, then you need it. One student can have many majors. One major has many students. Does that make sense?
I guess I'm still stuck on the what, because it's just one student. So how does that?
Well, every row is one student. This represents the student table will actually have thousands of students.
Oh.
I did this a little bit Actually, I did it last period, but I don't know that it's coherent enough to read. So this is like major ID name English database math. I'll redraw it if you want. And then I have the student. I have Joe, Sue, Mary, and Bill. So look at 2. Sue is 2, so that's a student ID 2, student ID 2. The major ID is 2 and 3, right? So one student, 2, has 2 majors, 2 and 3. And the others, like Joe has 1 major, 3, and I think Mary and Bill both have just 1 major. Right? Nobody's majoring in English for some reason, which was my major. You want me to redraw it, or does that make sense? That's when you're talking about one to many, you're talking about it for each row. But the relationship between the tables means that any record in this table can have many related records in this.
That's why it's many to many.
Yeah, and in order to do a many-to-many, you have to resolve it with a linking table like this. All right, so we would need a student major entity. And you could do like this is not required, but again, I usually do this by doing a composite key. You don't have to do a composite key. Okay. And you could have a lot more information about a major. I mean, this could get much, much bigger than it already is. Yeah.
Are you sure you want to name a major ID? Because we already have a major ID.
It's perfectly fine.
Okay, and are you sure they're both PKs?
Yes. It's not 2 PKs. It's 1 primary key that has 2 pieces. So it's what they call a composite primary key. There's only 1 primary key, but it has 2 attributes in it. It's like this. All right. So again, Sue has 2 majors. So her number appears here twice, but the major ID appears here 2 and 3. The combination 2, 2, 2, 3 is unique, right? It's the combination that has to be unique. The pair has to be unique. So you can't assign the same student to the same major twice. That's the advantage of doing a composite key. Disadvantage is you have a complex key, a 2-part key. Does that make sense? Also, it is a naming convention. It's not required, but it is a naming convention. So these are both foreign keys as well. I didn't put that there, but they are. So I could put PKFK because they're both primary keys and foreign keys. Foreign keys typically are named the same as the primary key they refer to. They don't have to be. That is not a database rule, but it's a normal naming convention. Major ID, major ID. It can get confusing if you name them differently. Does that make sense? Though you can. You could say major FK instead of major ID if you wanted or something. They don't have to be the same name, but typically they are. So that's like student ID here. It's the same as student ID up there. It just makes the relations clearer, although it does have some secondary drawbacks. When we do queries, we'll have to qualify them a little bit. Yeah.
Trying to think of how I explain my question, but so like is each unique individual student going to have their own like student major entity, or is like the student major entity going to have all of the students in there?
It will have all the students and all the majors.
Okay.
So we're dealing only with the headings, but every single student that has a major will be listed in here. if they only have one major, they're listed once. If they have two majors, they're listed twice. If they have three majors, which most schools won't allow, then you're listed three times.
Okay.
Does that make sense?
That makes sense.
Just like, so all the students everywhere basically will be listed in there, and they'll be listed in here too. Now, a course may only have 25 students, but that's that section, right? That section ID will repeat 25 times, and then the student ID will change each time, right? And then the next, but they're all the sections for all the courses are in the section roster. This could have hundreds of thousands of records in it. Basically a history of every section and all the enrollments in those sections. And what changes is the section ID. That's what it refers to that. So the section ID refers to the section, which then tells you what course it is. Grade should go away from course. We'll move that already. Other questions? Well, I'm going to draw the pictures for the relationships here in a minute. Yeah.
In the student major entity, like how does it know, like if it's, you said it's a composite key and it has to be unique with both, like a combination of both of them. How does it know, like for one student, how does it know the combination of both of those for that single student?
Well, the student ID repeats twice, right? So like here, Sue is 2, 2, 2. Student ID is twice. Major 2, 3. Combination 2, 2, and 2, 3 are unique. They're different from each other. Some other student could major in 2, like 4. So the student ID is 4, and the major ID is 2, but 4, 2 is still a unique combination. Does that make sense?
Yeah, I think so.
So this can repeat for the student as often as if the student has multiple majors, it just repeats the student key. The major key can repeat for as often as there's a student that's taking it.
Gotcha.
It's possible. I mean, it works. I don't know if trust me is. And again, you don't have to do a composite key. If you really wanted to, you could just do student major ID and just make these foreign keys. There wouldn't be any protection against accidentally assigning someone to a major twice if you do that. But other questions? Again, I'm going to draw the relationships here. You guys can kind of see the relationships already. But is it making some sense? I don't expect this all to sink in instantly. I don't. These are good questions. Any other? So, I mean, the relationships are basically, you know, student to student major, major to major. Couple of.
So I thought it was many.
One student, many majors, possibly.
Okay.
One major, many students, possibly. So this is the one side, this is the many. You thought it was reverse?
I just want to listen.
No, you don't. Go ahead and ask. You don't have to point. These are just pointing to the entities. They aren't necessarily hooked to the fields. You just have to sort of know that by reading. You know, you're just hooking to the box, not to the particular field. All right. So student again, I'm going to go from here to here because one student can be in a roster. The section, let's see, we've got course. So we got course ID. We need to, there's course, where's section? Section's way over here. I'm going to let it arrange in a minute, but I'm trying to arrange a little bit. So course goes to section because one section can have many courses over time. Did that link? There we go. The section comes up to here. Building goes to here. Right, so we're just linking the primary keys and foreign keys. One building can have many rooms. Now, it's not necessarily true that one room would be repeated many times, but it is possible because there are times when people share a room. And then the advisor, we didn't do anything with the advisor. Does a student have only one advisor or multiple advisors?
Multiple.
So then we would need,
One to many.
well, it'd be many to
No,
many,
many to
yeah.
many,
So
yeah.
you would need a linking table. If one student can have many advisors, then you need a linking table. And somehow I've got them at opposite ends of the thing here. But we can do that.
You forgot to link the room ID in the section.
Oh, yeah, which we can do.
Would advisor have a relationship to building as well?
They do sort of. They have the room ID. They wouldn't have a relationship
Oh,
to
okay.
building because building is
So
here.
it goes to the room and
Yeah.
goes to the building.
And then advisor needs to, we need a, I'm trying to make room for a student advisor. So I'm going to do this one the other way. So I'm going to say student advisor ID. I still probably would actually in real life use a, and then I'll do like a student ID and a, advisor ID. You might actually in some of these, like this is a kind of, come on, let me move it. Come on, there you go. You might have other fields here. It's more than a linking table in some ways, because you might have like the dates that they were assigned. Does that make sense? I'm going to just add a date on here because this, one reason to do this would be that a student could have multiple advisors over time and could sometimes come back to the same advisor at a different time, right? Have one in between and stuff, so that might give you. It actually doesn't hurt to put dates in everything, like just date entered. So we have student advisor, so let me move advisor again. We go over here, and then we have to go from student somehow down to here without making a total mess, which I don't think I can do. I think we've got everything linked, right? It's a bit of a mess, and I may let it arrange in a moment. There are other things that we haven't dealt with, like I don't know if we want to right now. Like department. I think we have advisor department. So an advisor would probably belong to a department, but a major would also belong to a department. You know, there's all sorts of other things, but we'll leave department out for right now. This is we had one table. And then after going through normalization plus the many-to-many thing, and we now have 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there one below there? 10. We now have 10 tables. 10 entities. And that's not atypical. One of the things about relational databases is that they're complicated. It is a fun puzzle for, well, if you have a certain mentality, it's a fun puzzle. Otherwise, it can be kind of a frustrating thing. So it's up to you. It takes a while to get the hang of this. You guys are doing pretty good on it, actually. I'm going to post this too, and I'll make it a little bit bigger, I mean, a little bit smaller so you can see all of it. Questions on this? Does this make sense? We don't necessarily have all the attributes that we need either. You know, I haven't filled these out with all the information you might be wanting to keep on these things. You probably have more information about the student. Let me arrange it and see how it pops out.
Like, what else would you have on the student, like, besides their ID?
Well, so if typically
Their address, your address.
you'd probably have their address, phone,
number.
and typically they want, although these are often optional, all sorts of
When they've lived here.
yeah, and demographic information. They usually want, you know, things like gender identity that you identify with, racial background. I mean, those things. The reason they want those is that if you're applying for government grants, they want those stats. So, I mean, they typically have a lot more stuff there. Some of it would have to be optional, right? When we start building databases, actually building them, which we may be doing as early as next week or a little after, we'll have to worry about not only what fields are going to be, but what data types are going to be and whether they're required to be. Those are the big questions. So I'm going to see about arranging this. See what we get. So, and I'm going to zoom down just to see what the whole pattern looks like. I can zoom up a hair. It doesn't move too subtly here. If I do that, it won't all fit. I'll post this picture. I do like the arrange. It makes it into, it's not necessarily the optimum. It's arranged in kind of a hierarchy here, you know, in terms of descending. We could probably make it more compact.
Do you normally read from the middle or like I would go to the student and start going out?
So yeah, you could do student in some ways is the most important. It has the most connections. So you could do however you want to organize it. A hierarchical arrangement here isn't necessarily always your best, but it does tend to, when you have a mess, it tends to unmake the mess, and then you can move things around again if you want. Couple of things about the way these work. If I wanted to know all the students that have a particular major, you know, I can go from student to student, major to major. As long as you have a path, however tortuous, like if I wanted to know which courses student, which advisor advised a student to with certain courses, I mean, you could get that. You could go from course to section roster to student advisor to advisor, right? As long as there's a path, you can get that data together. And again, the idea is you should never repeat anything. Everything should be in one place or only one place. You could go one further thing because every student has a name and an email and probably a phone, and every advisor has a name, probably an email and a phone. You could combine those into like a person table and then just use a foreign key to separate out students and advisors and faculty if you added faculty. I often do that actually. All right. Other questions on that? Does that make sense? That's the process. Basically, you take your data and you break it up into ever smaller pieces. And remember, this is more for the database to be read by the computer. When you're designing a relational database, you're defining these into discrete sets so that the computer can handle them better. It has other things for human things. I will show you later how to make views and things where you bring the data back together for people to see and understand. Yeah.
What is generally the kind of information or data that you would put in a linking table, other than obviously the?
So if it's purely a linking table, it's usually just the keys of the two tables you're linking.
Gotcha. Because we had the one example where we put some
right. So one of the things I think in the book I wrote, I said sometimes you discover an entity you didn't realize you needed.
Mm.
So for instance, when we did
student advisor?
Yeah, student advisor, we realized that there are some things that might go in there beyond just the linking. So that maybe this is an actual entity of itself.
Hmm.
A linking entity, pure linking entity is just the foreign keys. But sometimes you get there and you say, oh, this would be the right place to put other information, right? And then it's not strictly a linking entity anymore. But it's still performing that function among others.
Mm.
We don't have any like lookup entities. I guess you could say the major, the lookup table of just things to look up what the majors are. As I said, this would imagine what would happen if we add faculty and add department. It starts to get even more complex. Okay, so are other questions on this? As I said, this is hard. I did record it, and it will be, I'll post everything I'll post this, and I'll post the diagram, right? I would post both diagrams, but I think I destroyed the first diagram in making the second. All right, so the other thing I want to show is the assignment, and I want you to get started on this, but I will give you Monday to work on it as well. So, a couple of things. This is the entity relation first draft, right? And it's based on Vincent's vinyl. We did this student thing, but this will be based on the record store. And the goal is to come up with a diagram kind of like what we just did for Vincent's. And I want you to work on it in groups. I'll show you how that'll go in a moment. So we want the entities and attributes, and we'll do it as a group, but you'll all turn it in individually. That way, if there are people that don't contribute, they don't turn it in, they don't get the credit, that kind of thing. Also, it allows you to do what they sometimes call as a minority report. If you disagree with your group, you can turn in an alternate version and get away with it. So one of the things you can do is you can, this is Visio, but since most of us are using Lucidchart, you can save it as a PDF and upload it, or you can share it. All right, if we go back to this chart here, it has a share. And one of the shares you can do, so we need to name it. So I'll name this as student ERD. And I'll save that. And then you can get a shareable link. And if you put that into Canvas, one of the things you can do is just post a link in Canvas. And then I can look at this from mine. Right? So I'll have a shareable link. I can look at it. So you can do that. You don't have to necessarily save it and upload anything. You could just give me the link to your Lucidchart if you're doing that. And this is kind of like Google Docs, right? They give you a shareable link, which is some really impossible, ridiculous URL.
Almost exactly the same.
Yeah. Well, actually, I'm pretty sure that Google owns Lucidchart.
Yeah.
So, I mean, there are basically three companies that own everything. 3 or 4: Amazon, Google, and Apple, yeah. Microsoft too.
Microsoft. Yeah.
So 4 companies that own everything. Okay, so that would work. Let's go back to the. Okay, so as I said, I'm going to now. One of the things I'm going to say is don't worry too much about the rubric here, because basically with this one, I just want you to get a good rough draft of this as good as you can, and then I will come and meet with each group, which in this class will be easy. There's not going to be a lot of groups. And we'll go over them. So you basically get all these points. And I'm not going to require you to present that. I'd forgotten that was still in there. But we'll just meet and go over them. And that could maybe happen Monday. It depends on how far you get along, because I will give you Monday to work on this. You can have now and Monday. So if you go to people, I don't know if I'm still in student view. I am not. So if I go into settings, go settings and student view, and then if you go to people, you'll see that there are groups, and we don't want Python Club, and we don't want Show Tracker, we want Vincent's. All right, and basically they're self-join, so you can join your own groups. There's 10 of them, which is far more than we need. When you make a group, they say, how many do you want to make? So I just said 10. And 3 to 4 in a group is good. I guess if there was a 5-person group, that would be all right too. But you can self-join. Again, the groups are basically just so you have people to discuss it with. You still turn it in individually. If on Monday, if there are people that haven't joined groups, I may just add you. But this is a small class. I would probably figure you got 5 people on this side. That might be a group. Maybe break this into 2 groups. And when people come Monday that aren't here, we'll add them as needed. Questions on that? So today what I would do is just sort of start talking it out, get to know who you're working with. As I said, I will give some time, maybe on Monday, if we'll have time, if you get a good rough draft, we can talk about it, even on Monday. Monday, we will also download the virtual machines, I think, because we can work on one while the virtual machines download in the background. They're on the machine, but it would be a good idea to copy them to like your documents or something, so that, because right now they're in a public folder. And it would be really good if they were in your folder so nobody else can mess with them. Also, if they crash, there'll be something to go back to and get a new one. So we'll do that on Monday too. So what else do I want to do here? I think, I was going to show you. I'm going to go to the modules. So there's this Vincent's PDF, which you can use to kind of go off of. The one thing I want to mention, so if you look at the for opening paragraph in the scope, business rules you can kind of pay attention to, but don't worry about these tasks. That's from a previous iteration of the class, and I never eliminated them. So you don't have to define the stakeholders and write that up. You don't have to do a brief narrative for each stakeholder. You don't have to define the security requirements. For Vince, there's not much. There should just be a login. The requirements, we kind of did that. We did some of that. And you certainly don't have to present under the class. But this will give you kind of an overview of what the database is about again. The other thing I want to do, so I'm going to go to the syllabus. And I'm going to go to the blog. Now, this is from normalization this morning, which you can look at. We did entity relationships, that's from last time. But if you go way back, we talked about the different parts here, like the different kinds of things, reporting, inventory, point of sale, customer, purchase requests. So those things that we talked about last time, apply, right? Remember when we talked about those in class? These could be entities, inventory, point of sale. Now, they may not be sufficient entities, right? We were just doing broad groupings. But those are the places to begin with, things to start with. So those are there on the blog. Everything is on the blog, and I'm going to put what we just did on the blog, and it's always top to bottom, so you might have to scroll down to find what you want, you know, for that. That's the afternoon notes. You can look at the morning notes if you want. You guys actually do better than the morning, maybe because it might be the difference between being like 16, 17 people and 30 people. Or you're just smarter. What you go with that?
Let's go with that one.
Questions? So I'm going to let you guys get started. I'm going to post things here while you get going. And if you have questions, let me know. As I said, I will give you Monday. With group stuff, I try to give quite a bit of in-class time. I'll try to watch to make sure I'm not giving you so much time that you're bored, but I do want to give you enough time to get most of it done because it's hard to meet out of class. Question? You look like you had a question.
I did,
So,
I prefer you do groups. I know some people prefer to do individual, but I really think it helps to brainstorm. Which group you are, you can decide. Maybe 1, 2, 3. Oh, and I need to stop the video. I didn't start it. Now I have to stop it.